The sun, a giant ball of burning gas. It dominates our sky, a beacon of light and energy. It is the source of our life, providing the essential energy that sustains all living things on Earth. Without the sun, our planet would be a frozen wasteland, devoid of the warmth and light necessary for life. The sun provides us with light and warmth, creating the conditions that allow life to flourish. It drives our weather patterns, influencing the climate and weather systems that shape our environment. It fuels the growth of plants through the process of photosynthesis, which is the foundation of our food chain. Everything we need to survive, from the food we eat to the air we breathe, is connected to the sun's energy. But the sun is not eternal. It has a finite lifespan, just like all stars in the universe. Like all stars, it has a life cycle. It was born from a cloud of gas and dust, and it will eventually die, transforming into a different state. We are fortunate to exist during the sun's stable phase, a period of relative calm and consistency. This is a time of relative calm, allowing life on Earth to thrive without the threat of extreme solar changes. Understanding the sun's life cycle is important for our knowledge of the universe and our place within it. It helps us appreciate our place in the cosmos, reminding us of the delicate balance that allows life to exist. It reminds us that even stars are not permanent, and that the universe is in a constant state of change and evolution. The energy from the sun travels millions of miles to reach us, taking about 8 minutes to make the journey. The sun is also a dynamic and sometimes volatile star, with solar flares and sunspots that can affect space weather and even technology on Earth. Scientists study the sun to understand its behavior and predict its effects on our planet, using advanced technology and space missions. As the sun sets each day, it symbolizes the end of a cycle, only to rise again and continue its vital role in our lives. Each sunrise brings a new beginning, a reminder of the sun's enduring presence and its importance to our existence. Throughout history and across cultures, the sun has been revered and worshipped, symbolizing life, power, and renewal. It has inspired countless works of art and literature, capturing the imagination and wonder of humanity. The sun is a constant in our lives, a reminder of the natural forces that govern our world and the universe beyond. It stands as a symbol of hope and continuity, a testament to the enduring power of nature and the cosmos. The sun began its life as a vast, sprawling cloud of gas and dust, floating aimlessly in the cosmos. This cloud, known as a nebula, was cold and dark, a silent and mysterious region of space where the seeds of stars are sown. Over millions of years, gravity, the invisible force that binds the universe, slowly pulled the gas and dust together, causing the cloud to collapse inward. As the cloud collapsed, it began to spin, a dance orchestrated by the laws of physics, spinning faster and faster as it shrank. This spinning motion caused the cloud to flatten into a disk, a vast rotating pancake of material, with most of the mass concentrated at the center. At the heart of this disk, the material became denser and hotter, forming a protostar, a young star in the making, glowing faintly as it gathered more mass. Eventually, the temperature and pressure at the center of the protostar became so immense that nuclear fusion began, a process where hydrogen atoms fused together to form helium. This fusion released enormous amounts of energy, lighting up the protostar and marking the birth of a new star. The sun was born, a brilliant beacon in the vastness of space. This monumental event took place about 4.6 billion years ago, setting the stage for the formation of our solar system and the eventual emergence of life on Earth. The sun is currently in a stage called the main sequence. This is the longest and most stable part of a star's life. During this stage, the sun fuses hydrogen into helium in its core. The energy released by fusion creates outward pressure. This pressure balances the inward pull of gravity. This balance keeps the sun stable. The sun has been in the main sequence for billions of years. It will continue to be in this stage for billions more. But the sun's supply of hydrogen is not infinite. Despite its seemingly endless energy, the sun is slowly but surely consuming its hydrogen fuel. This process has been ongoing for billions of years, ever since the sun first ignited in the vastness of space. Over time, the sun is gradually using up the hydrogen in its core. This hydrogen is the primary fuel for the nuclear fusion reactions that power the sun, producing the light and heat that sustain life on Earth. As the hydrogen is consumed, the core's composition changes, leading to significant transformations within the sun. Like a car running low on gas, the sun will eventually face a fuel crisis. This analogy helps us understand the gravity of the situation. Just as a car sputters and stops without fuel, the sun will undergo dramatic changes as its hydrogen reserves dwindle. As the hydrogen in the core is depleted, the fusion rate will slow down. This slowdown is a critical phase in the sun's life cycle, marking the transition from a stable star to one that is beginning to age and change. This will cause the core to shrink and heat up. The increased temperature and pressure in the core will eventually ignite helium fusion, a process that requires much higher temperatures than hydrogen fusion. The outer layers of the sun will expand and cool. This expansion will be so vast that the sun will engulf the inner planets, including Mercury and Venus and possibly even Earth. The cooling of the outer layers will give the sun a reddish hue, transforming it into a red giant. This is the beginning of the end for the sun as we know it. The stable, life-giving star that has been a constant presence in our sky will undergo a dramatic transformation, altering the solar system as we know it. The stable, life-giving star we rely on will begin to transform into something entirely different. This transformation is a natural part of the life cycle of stars, but it will have profound implications for our solar system and any life that may exist within it. The sun's journey from a stable star to a red giant is a reminder of the dynamic and ever-changing nature of the universe. Section 5. The red giant emerges. As the sun's core shrinks, it will get hotter. This will cause the outer layers of the sun to expand dramatically. The sun will become a red giant star. Red giants are huge and cool. They are much larger than our sun is today. When the sun becomes a red giant, its outer layers will extend beyond the orbit of Earth. This will have catastrophic consequences for our planet. The intense heat from the expanding sun will boil away our oceans and vaporize our atmosphere. Section 6. Mercury and Venus consumed. Before Earth meets its fiery end, the inner planets will be the first victims of the sun's expansion. Mercury, the closest planet to the sun, will be the first to go. As the sun expands, Mercury will be engulfed. The small, rocky planet will be vaporized without a trace. Venus, the second planet from the sun, will suffer the same fate. These planets will be completely destroyed. They will become part of the expanding red giant sun. Section 7. Earth's uncertain fate. The fate of Earth is less certain. Some scientists believe that Earth will be swallowed by the expanding sun. Others believe that Earth might be pushed into a wider orbit. If Earth is swallowed by the sun, it will be vaporized like Mercury and Venus. If Earth is pushed into a wider orbit, it will survive the red giant phase. However, even if Earth survives, it will be a very different planet. The intense heat from the sun will have stripped away its atmosphere and boiled away its oceans. Section 8. The outer solar system transformed. The outer solar system will also be affected by the sun's transformation. The icy moons of Jupiter and Saturn might become warm enough for liquid water to exist. These moons could potentially become habitable. They might even support life. However, this is just speculation. The outer planets themselves will survive the sun's red giant phase, but their orbits will be altered by the sun's changing gravity. Section 9. A white dwarf's glow. After the sun has exhausted its nuclear fuel, it will shed its outer layers. These layers will form a beautiful planetary nebula. This is a glowing cloud of gas and dust. The sun's core will remain behind. This core will be a small, dense object called a white dwarf. White dwarfs are incredibly hot. They emit white light. However, white dwarfs are not very luminous. They are much fainter than stars in their main sequence. This is because they are no longer generating energy through fusion. Section 10. The end of the line. A black dwarf. Over billions of years, the white dwarf will slowly cool down. As it cools, it will emit less and less light. Eventually, it will become a cold, dark object called a black dwarf. Black dwarfs are the final stage in the life cycle of a star like our sun. They are no longer visible. They are incredibly dense. Our sun will not become a black dwarf for trillions of years. This is far longer than the current age of the universe. Section 11. Conclusion. A universe of stars. The sun's life cycle is a reminder of the vastness and wonder of the universe. Stars are born, they live, and they die. Our sun is just one of billions of stars in the Milky Way galaxy. And the Milky Way is just one of billions of galaxies in the observable universe. The universe is filled with stars in all stages of their life cycles. By studying these stars, we can learn more about our own place in the cosmos.